If you've been following the AI news lately, you've probably sensed that AI agents are about to take off. In this video, I want to provide a brief introduction to what AI agents are and how they are different from using standard large language models. Firstly, let's talk about how AI agents are different from using large language models like ChatGPT. When you're using the ChatGPT interface, you might have noticed that although it's very powerful, it requires quite a lot of your own time to get to a desired output. For example, if you ask it to write you a marketing copy, you might notice that it will give you the first draft and you need to ask for it in a different tone and then ask it to rewrite it or make it shorter. And actually that's taking quite a bit of your own time and oversight in order to get to a decent enough output. And so in a similar way, a big part of the idea behind AI agents is introducing this iterative nature where the LLM is able to reflect on its output and also giving it tools to allow it to have certain capabilities beyond what the LLM is able to achieve on its own. In order to better make sense of this, Andrew Ng from Deep Learning AI, who is a top AI researcher, created this framework for better understanding what are some of the key trends in AI agents. The first one that I would like to discuss is planning. At the moment, when you use large language models, there's not really a lot of planning that's happening in the background. The LLM is simply responding to the prompt that you provide it, and it's executing on that specific prompt. With AI agents, however, the LLM is programmed to reflect on that task and break it down into smaller subtasks, which it will then act on one by one until it has completed the overall task. And in doing so, this introduces autonomy, as you're not having to oversee the LLM in every single step, and it's able to work on its own. One recent example of this implementation is Devin, which made quite a big splash as it promised to be an AI developer that you could work alongside and would just be chugging along, writing code, fixing bugs, identifying things. And I think the level of autonomy that this represented was quite a shift and quite a surprise for a lot of people. The next element of AI agents is the introduction of tools. You've already seen this in applications like ChatGPT, where you're able to download certain plugins, and increasingly they're starting to bake in tools that the LLM is able to use. So let's say, for example, that you ask an AI agent to research this new laptop which has just come out and give you the pros and cons compared to its competitors. Seen as LLMs have a knowledge cutoff date, the agent might know that it should use a web search tool. And in doing so, it can gather the most relevant information and it's no longer hindered by its knowledge cutoff in the training. Alternatively, you might ask it a maths question, like what is 100 times 7 divided by 5? The agent will hopefully know that it shouldn't rely on its transformer architecture to do this. It's not optimized for mathematical problems. And so it could call a tool or write some code, like a code execution tool, in order to figure out the answer to this problem. And by granting the agents these tools, we're able to allow them to act more powerfully in the world, as they might be able to check the weather via calling an API or book certain flights or book a hotel room for you. And that was a big limitation of the previous LLMs, that they were a bit like trapped in this container and not able to really bridge the gap between acting on certain requests. Lastly is allowing the LLM to reflect on itself. So one feature that researchers have discovered is that often if you ask the LLM to provide an output, such as write me the code for this function, if you then paste in the same code and ask the LLM to carefully check it for accuracy, efficiency, and any bugs, oftentimes it does actually identify any bugs and makes the code better. So by adding this iterative loop, the end outcome you can get is much better. And this can happen multiple times in a succession. Of course, you could bake it into the agent just to iterate on its response a couple of times to check for its performance. But one thing that researchers have found is that if you create another AI agent and specialize it in reviewing the output of the other AI agent, this can actually lead to really good results. So as an example, if you have one AI agent, which is a coding agent, you can create another agent, which is a code review agent, which receives the output of the code agent and then specifically feeds back, identifies bugs, suggests improvements, and the end outcome has tended to be much better. And by introducing these concepts, you essentially have a system which learns and is able to improve on itself over time. And this leads me to the final trend, which is multi-agent collaboration. As you saw in the previous example, creating a separate agent which specializes in a different role, which interacts with the coding agent, can lead to better results from the agents overall. And so once you connect multiple agents and take advantage essentially of division of labor and set them as different types of roles within what is like an organization, such as a coder, a product manager, a QA tester, etc., and have them work together, you can actually get some interesting emergent outcomes and get results that are a lot more sophisticated and complex than if you just had used one agent to try to produce everything. This is actually a very interesting concept which is really starting to gather momentum in the past months, which I would like to also dive into in a future video. So I hope that was a useful introduction to what AI agents are. I will add some links in the description of further resources and readings, in particular Andrew Ng's series of articles, which this video was based on, and look forward to seeing the next video.